Hi everyone, this is Carlos with the Emacs Science Support Team, and today we are going to be looking at transit least squares. Transit least squares is a least square algorithm to detect planetary transits from time series photometry. It works a lot like box least squares, except instead of searching for rectangular signals in Starlight, it searches for transit-like features in Starlight. We are also going to take advantage of one of the newest additions to Emacs, which is the Jupyter Interactive Notebook button. So if we click here, it will take us to mybinder.org, where mybinder.org will begin to make an interactive Jupyter Notebook repository. We'll click on this one just to get a quick start with some synthetic data. So one thing you will notice right off the bat when you try running this code, you will get this error. It says no module named matplotlib. No worries. This is expected. All you have to do is pip install matplotlib, run it, and it will install right away. We will also need scipy to run this notebook because at the end of the notebook, the last cell requires it. So we'll go ahead and pip install that as well. Once it is done being installed, we are going to go ahead and get rid of this, and we will restart and run the whole kernel just for quickness. So what we are doing here is we are creating our own synthetic data. Using Batman, we will create a bunch of transits. And for those of you that are unfamiliar with Batman, Batman is also a tool hosted on Emacs, and we do have a tutorial for it that will be in the description below. So let's look at our data. Here we have some relatively clean data. Well, it's clean because we made it up. And no transit, at least none to the naked eye. Now, we're going to go ahead and run TLS. All it takes is 3 lines to find some of these transits. And that's what TLS will do. It will find these transits for us. So we're going to give this a second to load up. Okay, it is all done. It only took 2 minutes and 23 seconds. Now, let's go ahead and print some of these results. So, looking at the period and the transit depth, the best duration, and the signal detection efficiency, we can go ahead and print. Use format and use results dot and then the parameter you want to see. So for example, results dot depth, results dot duration, results dot SDE. And here we have our values. Now to visualize that, we will go ahead and plot. We're going to plot 2 things. We'll plot SDE versus period, and we will also plot phase versus, I need that. You're good. We are going to make 2 plots. We are going to plot SDE versus period and phase versus relative flux so that you can see this transit really well. So here we are. Beautiful transit of synthetic data using TLS. And all it took was 3 lines of code. They also went ahead and included this prettier plot of the same data where they binned it, and they included this nice little joke for us. Binning is sinning. So yes, remember, binning is sinning. Don't over bin. So yeah, super simple and easy to use. Now, if you are a contributor and you also want to add interactive Jupyter notebooks to your Emacs submission, you can go ahead and go to mybinder.org. Where it will show you how to create your own. So all you do is go to your GitHub and you will copy and paste that GitHub into this URL path. You will go ahead and write main or master here in this get ref. Mine's is main, I believe. And if you have your notebook that you want us to see in a specific folder, like for example here in folder 2, I would write /folder2/ in this path to notebook, and then hit launch and copy that and send it to us. So yeah guys, that is TLS. I hope you guys liked it. Again, there's tons of stuff it does. There's 11 tutorials here ready to go for y'all to use. And yeah, happy exploring and have a great day. Peace.